Hello and welcome to Generative Media Coding. For our first exercise, we will do a Hello World type of exercise. So I will show you how to write some text to the screen. Okay, so I will open XCode first of all, and then we'll see different ways to start an exercise in openFrameworks. But for this example, I will copy a template that already exists in openFrameworks called empty example, and we will start from that. So later we will see how we can also build using other ways of organizing files in openFrameworks. So to use the empty example, so if you go to My Apps, you will see that there's an empty example there. I copied it to a new folder that I call GMC for Generative Media Coding openFrameworks. So I copied the empty example here. So one thing to know is that we are inside the openFrameworks folder, and I'll probably repeat this a couple of times, but your applications, your code sits on a kind of the third level from the root of openFrameworks. You always put your files on the not on the main folder of openFrameworks, not on a folder on the main, but on a folder inside a folder of the main. So you can think of it as the grandson of openFrameworks in a way. So we will see ways to get around this organization into this kind of third level or third tier way of organizing. But for now, we will keep it that way. So either you work within My Apps, or you create a new folder. So usually when I start a new course, I create a new folder just so that I have the new kind of all the new files inside that. Then it's kind of a cleaner way. So I assumed you've all downloaded the openFrameworks exercise from openFrameworks download. So in my case, I've downloaded it from the OSX folder, and once we have that, we get all these folders, add-ons, apps, docs, example, libs, other project generator, and scripts. Probably in class I will go more in detail through them, but a couple of things to know. The main ones we're going to pay attention to are add-ons and apps. So apps is where you put your code, and add-ons is where you extend the existing code. We're also going to take a look at examples, because there's quite a lot of useful examples here that can serve as your inspiration. And we'll also look at project generator later on. So this is another way to create files or to create your exercises with the project generator. But this has been a long introduction already. So let's go to apps. Well, you create your own apps, and you have the empty example. I'm going to duplicate that. So I'm going to duplicate, and I'm going to call this one exercise 1 Hello World. Okay. So what do we have in a openFrameworks folder? Exercise folder or example folder or app folder. Well, there are two main folders. There's the source, where you get the code files, and there's the binary or bin folder, where your application, when you export it, when you compile it, where your application will live. And the data folder is where you put any data that you want to load to your application, and that's something we're going to do right away. So once we have this example, we can double click the XCode project. So this is XCode proj, is the extension of an XCode project folder. Let's open it. It's a project downloaded from the internet. Are you sure you want to open it? Yes, I want to open it. And yeah, this is how basic XCode looks like. And this is our empty example. We're going to look at these definitions a bit later on. Now, I will show you within the source folder. So the structure you see in this left panel mirrors the folder structure that you have in openFrameworks in the folder that contains your example. So that you have the source folder here, and then you have all the components of openFrameworks. These are kind of the things that are under the libs of openFrameworks. I call this the under the hood part, so we don't need to go under the hood. We might want to go if we're curious, if we want to know how things work, if we want to tweak one or two settings, but by default we don't go so much under the hood. So to display kind of hello world on the screen, we have kind of two ways to do it, and I will show you both ways. So let's look at the files we have here. We have a main CPP, we have of-app-h and of-app-cpp. So when you see of, it's an abbreviation of openFrameworks. And I just say of, or I say OF, I mean, it means the same thing. Main is very basic, so it just gets a window running. So if you're familiar with the HTML, you know that in a folder there's always an index.html, which is the first file that is run. When your project is compiled, when Xcode compiles your code, that's basically the same thing. The main CPP is the first file that's going to be compiled and includes all the dependencies. So basically what it says here, this is C++ for include of OF main. So this is all the openFrameworks main code. And then it includes your code, the of-app-h, which means your application code. So of main kind of connects your application to the kind of core of openFrameworks, and of-app-h connects the main to the of-app-h. So what we have in openFrameworks in the of-app-h by default is a series of pre-made functions. And they deal with the basic mechanics of openFrameworks, and also the basic kind of interaction that you would have in a kind of typical graphical user interface or mouse and pointer kind of graphical interface mouse and pointer kind of environment. So you have key interaction, mouse interaction, resizing of windows, and kind of system messages. But the main thing to know is that you have a setup function by default, an update, and a draw. And the setup, basically, if you're familiar with processing, in processing you have a kind of a setup and a draw. The setup runs once when you first run the project or the application, whereas update and draw are continuous functions, and we'll see that one of the interesting things about openFrameworks is that it supports multi-threading, so you can have kind of graphical functions under the draw and more mathematical or not graphical functions under update, and they can run kind of independently from one another. It supports multi-threading, means that they run independently and that one doesn't slow up the other. So for example, if you're drawing something very complex and that's slowing down your system, it just slows down the graphic system, whereas update runs independently or should run independently. There are a few more quirks of C++ syntax that we will see here. But pragma once means that it will compile only once the things that stay the same. If you change things, it will only compile the changes. So the first time you compile, always takes longer. Then the second time, and so on, that you compile, it will only it will go faster because it will only compile the changes again. This code also connects to the main openFrameworks code, and what you have here is kind of your class, your main class, which is an OVAP class. It extends the base app of openFrameworks, so it doesn't. We don't need all the code of a basic application. It's all inherited this way. So C++ supports inheritance, meaning that you can extend classes. Then you don't need to repeat all the code which is in the kind of a template class. You only add your own code. And so you create a new class called OVApp. It's your app, which extends the of base app. And then you have a set of public functions. So in C++ you can set functions to be public or functions and classes to be public or private. We'll go a bit into that a bit later when we create classes, but basically it means that this class, other classes can access, can read, and can control what this class does because it is public. And that means also it's a bit more memory consuming than making it private, but then again, it makes it more accessible. So for the kind of basic things we're going to do, we don't need to set many things to private because we won't hit many walls in terms of memory management. So another thing to know in C++, and that's different from processing, for example, if you've used processing before, is that the code gets split up into two files. There's a header file, which is H, and there's the main class, CPP or C++ methods or implementation file. So where usually I describe this to students as, the H being kind of the table of contents. It creates the lexicon of what you will use, what you will implement here. But having a table of contents, so to say, is very useful for XCode because it allows for kind of automatic auto-completion and things like that. So when you type, because you have kind of a dictionary of terms here, when you type in CPP, because the computer XCode will know what you're trying to write because it's kind of defined in H, and it will also understand the context of things. Another thing that you might wonder is why you have void, void, void. So you probably saw this in processing, but functions can return values. That's very useful for mathematical functions. You can have kind of an arithmetic operation and then return an integer, for example. So when you return things, you need to specify what type of variable you're returning. But if you're not planning to return any value, so to kind of output a variable in the end, you just name it as a void function. And most of our functions would be void because we're going to be doing very graphical things or sound or things like that. So we won't create variables functions that will output variables. So after this long explanation, I'll probably show you a bit more in detail the openFrameworks website in class. I just want to show in documentation So these are the main areas of openFrameworks. We're gonna focus a lot in the graphics module, and one of the things that we will look into a lot is the off-graphics class. And there's very useful methods here to draw vector shapes, etc. One interesting thing is the off-draw bitmap string. So if you type off-draw bitmap string, you can draw a text, and anything we draw, usually you put in the draw function or you type it in the raw function. Basically, off-draw bitmap string has 3 parameters. The typical off-draw bitmap string, there's different ways to compose it, but the typical off-draw bitmap string has 3 parameters. There's the string that you want to draw, and then the x-coordinate where it starts to be drawn, and the y-coordinate where it starts to be drawn. So let's just do that. So where would we put it? We need to go to the CPP file, and then in draw, I'm just going to say of draw bitmap string, and here, if it's a string, you need the quotes, double quotes. So one thing to know is that well, we're getting an error that's saying no matching function. No matching function because although I think I don't have any typo, I could have, but I don't think I have. XCode is expecting a certain number of parameters, and I haven't finished filled it in, so it doesn't match that function with what it expects of a typical off-draw bitmap string. One interesting thing to note in XCode, if you saw, is that once we type certain things, it auto-completes for us. So if you put a quote, it closes the quote, it closes the parentheses, and that's very useful. Hello world would be our text, and then in terms of coordinates, let's put 100 and 100, and we finish. We always need to put a semicolon in the finish. It's like in terms of C++ punctuation, it's kind of equivalent to a full stop in English language. So okay, once we have it, we can run it. We can see is it working or not. And how I would do it is I press play. I press the this build button. So it takes a long time to compile the first time the empty example. Next times it will be a bit faster. So we should have, yep, here we go. We have Hello World appearing here. It's not very pretty, so let's try to write another Hello World with the font. This is the default font of openFrameworks. It's not very beautiful, but it's very useful because you don't need to load a font. But if you want a prettier font, what you need to go is to the font book, and that's how I would do it. You pick the font you want to use. Let's say I want to use, I don't know, Jill Sans, for example. So let's say I want to use Jill Sans regular. That's how I usually do. I pick the font from font book, and then I with a right click I pick show in Finder. And here we go. We have Jill Sans. The extension is TTC. So if you don't have the extensions visible, please make them visible in your system preferences, because it's really useful to have them visible. So once you've found the font you want to use, what you need to do is go to your app folder, So in my case, it's here HelloWorld, and you need to put the font you want to use inside the bin or binary data folder. You see here that you already have an app, which is the app you've just created, the HelloWorld that you've just created. So what I'm going to do is I'm going to alt drag this into the data folder. So here we go. We have Jill says TTC. We need to load this font into our app to have Hello World shown with this font. So now what I'm going to do is something a little bit different. So I'm going to go back to the to the documentation to show you something. So when we want to use media and kind of a font, you can see a font as a media. I call it media in any case. When you're loading media, usually you need to know what is the class that you need to use to manipulate that media, or what container you need for that media. So the media to be processed in openFrameworks, you need to allocate kind of a container to the media that will allow it to be processed. And each media has a class. In terms of text, what you want is the class of TrueType font. So of TrueType font has all these methods. We will need the draw string to draw the string, and we also need load to load the font. And when you load the font, you need to take into account that you need as parameters the file name and the font size, the size in pixels of the font to be loaded. When openFrameworks loads the font, it rasterizes the font in that size. So always pick the biggest size that you want to use the font in, because you can scale it. You can scale a raster image down, but you cannot scale it up because it will pixelate. But then again, if you don't need it as big as that, don't load it in such a big size, because it will fill up more memory the bigger it is, because all that raster information, that pixel information, will be carried in memory. So, okay, what we need to do, these are all the same steps for loading media. So in H, you need to create a media container. So how do you do this? So you need to type before the end of the class, so that this curly bracket marks the end of the class. So before the class ends, you need to invoke the class, and in this case it's of TrueType font. Please mind the capitalization, and we got this code completion functionality, auto completion functionality in XCode, which is very useful. And I'm going to call this font my font. So if you see the suffix, the prefix my, usually it's something I create. You can create whatever you wanna call it. It's kind of I use my. I could have used something else, Nuno font or whatever. But I'll use that. Never forget the semicolon. So once you create a container, you can load the font into the container. Then you can do anything. The same thing will go for images or for sounds. You need to load the media to a container. You name that container. I named it as my font. I could call it my pretty font or something like that. And then you load it into that. So in setup, let me do a comment, because these steps are going to be the same for all kind of media. So step one, when you want to comment, you just put //. So step one, create a container for the font, right? Then in setup, we need a step two of this process, and step two load the file into the container. So the container is my font, right? And we're gonna load the name of that file. I forgot what the name is, so I need to go back to the bin data folder. And usually to avoid typos or mismatches of case, etc., I just select the file name, I copy it, and then I put it in here. In terms of size, I don't know, I'll pick 100 pixels of size. So we've loaded the font file into the container my font. In update, we don't need to put anything. And now instead of, well, we can put two hello worlds, one side by side, right, of the other. So here, instead of doing, I'll draw a bitmap string, I'm going to say, what was the code again? It was draw string. So any functionality, openFrameworks has become quite consistent in that sense. So load is always load for any media, and then anything that implies draw always begins with draw in openFrameworks. So draw or of draw in the case of of draw bitmap string. So draw. We need the container. So my font draw string, and we have this auto-completion. So the string, the float x, and the float y. So the string is going to be as well hello world, whereas float x, I'm going to draw it in the same place. They're going to overlap, but we'll fix that later. For the exclamation mark, semicolon. So let's run it and see what happens. I still had the previous one running in the background, and if you run it again, it will close the previous one and open a new one. So there you have it. So you have the old hello world there being kind of smashed by the new hello world in the Jill Sans font. So now, if you want to get rid of the old one, we could just comment it out and run it again. And here it goes. Yeah, now we see the new hello world. And that's about it. So but just to wrap up, I can also show a couple more things within openFrameworks and XCode. So in terms of XCode, one thing, because in openFrameworks we're not using a lot of the native XCode functionality that is used, for example, to create applications in Swift or Objective-C. So we don't need these kind of native building blocks of XCode, so we can close it. So in XCode, you can hide panels. So you have basically a 4-panel layout, right? So you have a panel on the left, a panel on the right, a panel in the middle, and then a panel down there. So I can hide the right one like that. And the bottom panel is really useful because you have your console and you can print things to the console. We'll see how we're going to do that. There's a lot going on in XCode, so we're going to see things bit by bit. But one thing to know is these panels and how we can show and hide them. Another thing is that on the left panel there's kind of also a tab logic, and when you get errors, for example, you'll jump to the errors tab by default, and then you need to go back to your folders tab to navigate your files, right? Another thing to know is the numbers, the line numbers. This is in your preferences. So in editing, I like to have line numbers. So you can in the preferences in the text editing tab, you can show or hide them. Also, I like to wrap lines because what this does is that it collapses oh, sorry, this is the code folding ribbon, not the wrap line. Sorry, it's the code folding ribbon. What this does is collapse the functions. So if you have a lot of functions, and if you have a small screen, you can collapse them. Also, you see if they're well composed, meaning that if you have a curly bracket in the beginning and a matching curly bracket in the end, the computer will recognize. So if you have things like this, there's something wrong. So this it means that you've lost the curly bracket somewhere, right? So having this well-formed function setup that opens with a curly bracket and ends with a curly bracket, having this visual aid here of this code folding is really useful in my view, because curly brackets can be tricky. It can be XCode can give you good warnings of errors, but missing curly brackets is something that even XCode has trouble identifying and matching. And that's about it, I think. I mean, throughout different exercises, I'll probably highlight more things, but that's about it for this exercise.